Section 1.3 is simplifying radicals. Another way of saying that is finding the perfect squares. When you're finding the perfect squares, you're looking underneath a radical, a square root symbol, or a cubic symbol, and you're looking for those perfect squares, numbers that are multiplied times themselves. Today we're going to look at just the perfect squares, but this can be done with cubics, and we'll be doing those later in the year. So the first thing that we need to know is, what are the perfect squares? Well, the perfect squares are 1 squared, which is 1, 2 squared, which is 4, 3 squared, skip 3, 3 squared, which is 9, 4 squared, which is 16, 5 squared, which is 25, 6 squared, which is 36, 7 squared, which is 49, 8 squared, which is 64, 9 squared, which is 81, 10 squared, which is 100, 11 squared is 121, 12 squared is 144, 13 squared is 169, 14 squared is 196, and 15 squared is 225. These are the perfect squares that you should commit to memory. There are obviously more perfect squares. If I took, I could keep going, 16, 17, 18, 19, 20. 20 squared is 400. That'd be a good one to know. But continuing on in this, it's going to be important that you're able to find those perfect squares. This will be the fastest way. If you know the perfect squares, it'll be the fastest way to enable you to simplify radicals. So we'll take a look at this. It says simplify the following radicals. Number 1, the square root of 25. Well, if I look at the perfect squares here, I'm looking for a number that comes up to close to 25. Doesn't necessarily have to be 25, but it turns out that we actually have one. 5 squared is 25. So if I take the square root of 25, I get a 5. Okay, that's something you can punch out in your calculator. Same thing happens if I were to punch out the square root of 256. If I did that on a calculator, that actually is going to give me 16. And 16 squared is 256. When I look at number 3, there's a division problem in here. So inside this radical, I actually want to do the division problem first. So I do 98 divided by 2. So I get the square root of 49. And again, 49 is a nice perfect square. So I end up with 7. The square root of 49 is 7. Now here's where simplifying radicals becomes fun. Number 4, the square root of 80. The square root of 80, when I look here at my perfect squares, I have over here I have 8 squared is 64, 9 squared is 81. So 80 is not a perfect square, so I don't get a nice number after that. If I punch it in my calculator, it comes out to be a decimal that goes on for an extremely long period of time. That makes it an irrational number. Okay, all the other ones that we have looked at already so far are going to be rational numbers. They can be written as fractions. They don't have decimals that continue on forever. And so what I want to do is I want to look for the square root of 80. I want to look for numbers that go into 80, but I don't have to just keep randomly looking for numbers. I know that 9 squared is 81, so I can keep going below that. I can look and see, well, does 64 go into 80 nicely? No. Does 49 go into 80 nicely? And by go into, I mean, can I divide 80 by 49 and get a nice number back? It doesn't happen. I get a decimal. How about 36? Can I take 80 and divide by 36? No, it doesn't come back very nice. 80 divided by 25? No, not very nice. 80 divided by 16? Well, let's take a look. Well, my online calculator isn't working, so we'll give it a shot longhand. We're looking for 80 divided by 16. We don't know how many times does 16 go into 80, and so we take a look at that. If I do 5 times 16, 6 times 5 is 30. 5 plus 3 is 80. So 16 is a perfect square in here. I can write the square root of 80 as the square root of 16 times 5. And if I look at the square root of 16 times 5, I can take this and I can do the square root of 16. The square root of 16 is 4. The square root of 5 is not a nice number, so I'm going to leave it underneath that square root. And the square root of 5 is actually the part that makes the square root of 80 the long decimal that goes on forever. It's not the 4, it's not the 16, it's the 5 that causes that to be the decimal that goes on forever and doesn't continue working. So then one more of those, number 5, the square root of 75. I want to find a perfect square that goes into the square root of 75. So I start with 8 squared because that's 64. If I go 9 squared, that's too big. I can look, the next one up is 49. 75 divided by 49. That's not a nice number. 36. 75 divided by 36. Getting closer, but that's not good either. 75 divided by 25. Well, 75 divided by 25 is 3. So I know that 75 is 25 times 3. If I have 3/4, I have 75 cents. I know the square root of 25. The square root of 25 is 5. We just did that problem as the first one. And the square root of 3 is the part that makes this an irrational number. It's the part that makes that decimal continue without repeating. This is, again, the fastest way to do these problems. Let's take a look at one other way. If you look at number 7, we're looking for the square root of 18. Maybe you can already say, well, I know that 9 is in there, so I know that the perfect square is 9. But maybe you can't say that. So if you take 18 off to the side, you do know that 18 is 9 times 2, and 9 is 3 times 3. If I look for perfect squares, they're numbers that when I break them down in a factor tree, they become pairs of factors. Okay? Another definition for simplifying these radicals or square roots is that a square root is one of 2 identical factors of a number. So if I find the identical factors, then I can take those out. So that 3 can come out of the radical, but this 2 that's stuck in here has to stay in there. And so that's another way to do this type of problem, is find the factors, break down the factors until you find a pair of them. Take the pairs out and leave the non-pairs in. If we do that with the square root of 40, we're going to take 40 off to the side. 40, I know that 40 is 10 times 4, and 10 is 5 times 2, and 4 is 2 times 2. Here's a pair of 2's. The pair of 2's come out of the radical. But what's left inside is still this 5 times 2. Okay, all these things are multiplied. So I still have 5 times 2. So that 10 is actually the part that makes this a decimal that goes on forever. There should be no decimals on this worksheet. I want all radicals. Everything comes out to be a radical or a whole number. Well, when we look at the back page, the back page says to multiply and simplify. Well, the nice part about square roots is that if I have the square root of 12 and the square root of 3, that I can actually take and put those both underneath the square root. So this is the square root of 12 times 3. Well, 12 times 3 is 36. The square root of 36, I know if I go back here, look at my perfect squares, the square root of 36, here's a 36. The square root of 36 actually is 6. Comes out to be a nice whole number. If I do number 24, I have the square root of 10 times 5. Those two things multiply times each other, which is the square root of 50. The square root of 50 is not a nice number. When I type it into a calculator, I have the square, a perfect square would be 49. That's pretty close. So I need to start figuring out what goes into 50. Well, 6 squared is 36. 50 divided by 36 is not nice. 5 squared is 25. 50 divided by 25, oh, that works. 50 divided by 25. This is going to be 25 times 2. 25 times 2 is 50. And so the square root of 25 is 5. And the square root of 2 is not a nice number. So I end up there. Again, if you know your perfect squares, that's the fastest way to do this type of problem. If you don't, let's take a look at number 27. I still am going to have the square root of 10 times 15. But I want to break those numbers down. So one way to do that is just to multiply them. So I have 150. And I can find the perfect squares in 150, or I can find the factors that go into 150. Well, we just said that this was 15 times 10. 15 is 5 times 3. 10 is 5 times 2. Well, here's a 5 and here's a 5. Those 5s are factors, double factors in here. So I've got 5 comes out of the square root, and 3 times 2 is still inside the square root. So that's a 6. If I look at this in terms of perfect squares, 150 is 25 times 6. 6 quarters is $1.50. And I still end up with the same answer at the end. This topic is going to come back about 4 times this year. We need to make sure that we understand it and that we are able to break down radicals so that every time it comes up, we're not reteaching it or relearning it. We want to learn it right the first time.